So before we move forward and we go into various codes and various data structures, let's first discuss, it is important to discuss what is an algorithm. So, and as the session also says, course also says, data structures and algorithms. So what is an algorithm? So let's say, forget about computer. So let's say you're asked to multiply two numbers. Say you are asked to multiply two numbers. So what do? You're asked to just write these steps that how do you multiply a number. So what do? First, you say start. Just then what do? You accept number one. Accept number two. Because obviously we have to multiply two numbers. Then we multiply and then accept. So what is this? This is simply just a step or step by step. You tell me that if I ask you that how to multiply a number, you just step by step tell me that how do you multiply a number. This is an algorithm. So an algo or algorithm is nothing but just a step by step method of solving a problem. So we say that algo is just a step by step method of solving a problem. Okay. So, and we have another definition for it. We say that it is a sequence of finite steps to solve a problem. Algorithm is independent of any language. This is one of the characteristics of algorithm. So before we write a code, so if you're writing a small code, that's not a problem. But when you're going to write a big code, you actually need to design or write steps that, okay, how I'm going to solve this particular problem. So before you actually start writing a code, you just think, you write steps that, okay, these are the steps required to solve a particular problem. That is, that particular steps, that set of step is called algorithm. This algorithm is independent of any language. It just gives the logic. It has no interest in the programming language that you use. So why do we need a programming language? We don't need a programming language to solve a problem. We need a programming language. It's just a tool so that after we solve a problem, we can run it in a computer. For that, we need a programming language. So, but before that, we actually need to solve the problem. We need to write the steps. So these are the steps. And does not matter that you write this step in English, Hindi or Malayali. You can write this in any language that you want. Now, few things to note in this particular definition is, it is a sequence of finite steps to solve a problem. Okay, we discussed this and we also write down few properties of an algorithm that you need to take care of. So these are the properties, this sequence, the sequence thing is also a property of an algorithm. It should take a finite time. By this finite, we means that it should take a finite time, and this should be independent of programming language. So no matter, it's not that if you are implementing an algorithm in Java, then the logic gets changed, and if you are implementing it in C, the logic gets changed. The steps that we have to do has to remain as it is, independent of the programming language we are using to implement the algorithm. Next we have, it should produce at least one output, and we have deterministic. Coming back to sequence. So in this case, can we change the sequence of this algorithm? Let's say we accept number one and we try to multiply. Is this possible? No, it is not possible. So the sequence in an algorithm cannot be changed. It should not be like, doesn't matter whether you are writing this first or this first, it will work. It should not be that case. So the sequence has to be maintained, and there should be a reason that why this particular step is taken after this step and not before. Next we have finite time. So let's say we have an algorithm that takes a while loop. What will happen in this case? In this case, the loop will keep on executing till infinite time. Is this an algorithm? No, it is not. Because it is taking infinite time to execute, and we want that whatever algorithm we have takes a finite amount of time and gives us a particular result. Again, I've already discussed what does independent of programming language means. Next we have produces at least one output. So let's say I am giving you I need an algorithm that for that matter adds two number, and we give A and B as an input. So we need whatever steps we do, we need some output, we need a sum. So the algo should, whatever steps it has done, it should produce some output. Next we have deterministic. So let's say we have A plus B minus C. Okay. So what should happen in algorithm is, if we have a particular step, no matter what, no matter the amount of time, no matter what, this particular step or a particular step should give me the same result every time it is getting executed. So if we are accepting two numbers and multiplying, that no matter how many times I have done the multiplication, no matter what input I have given, it should be deterministic, that okay, if the input is 3 and 4, the output has to be 12 no matter what. One more thing is, it should accept 0 or more output. Sorry, input. So the algo can have 0 or more input. So this is all about algorithm. Summing it up, summarizing it, it is nothing but just a sequence of steps that we write to solve a problem. It could be just a logic. It just needs to tell that how we are going to solve a particular problem. That is all about algorithm.